Welcome to a lesson with Dr. Powell. Let's talk about a quick way that we can multiply out something like this, x plus 1 raised to some high power like 5 or 6 or 7 or something like that. There's a nice quick way of doing this. But let's start off with looking at just multiplying x plus 1 times x plus 1 together. Now, this actually looks a lot like multiplying 11 times 11 in a normal arithmetic. How so? That's because 10 or 11 is the same thing as 10 plus 1, which is the same as if x is equal to 10, then this is the same as saying x plus 1. And really the same algorithm that we can use at this point works over here just fine in multiplying. In fact, if we had like 111, imagine what would happen. This is actually equal to 100 plus 10 plus 1, which is like 10 squared plus 10 plus 1, which is like x squared plus x plus 1. There's polynomials lurking all over the place here, even with regular ordinary place value. So let's look at this and just think x plus 1 times x plus 1 using this algorithm. 1 times 1, 1 times, so 1 times 1 is 1, 1 times x is x. Then we move over here. X times 1 is x, and x times x is x squared. Then we add 1, 2x, x squared. Couldn't we have just done that if we did 1, 1, 1, 1, just thought about coefficients? And think 1, 1, and think when you multiply by this guy, you're going to shift up in place value because it's like an x here, and it's or like a 10 or whatever, and it just shifts the place value, so you go 1 over just like you would normally. So that's a 1 there and a 1 there. Then you add 1 to 1. We're able to arrive at this result simply by thinking about normal arithmetic, like 11 times 11 even, to get to end up with this, and understanding what this means. This means x squared plus 2x plus 1. Okay, so let's keep going with this. So x plus 1 times x plus 1 gives us 1, 2, 1. Then we multiply by another x plus 1, and 1 times all that is just this line, and then 1 times all that is the same line just shifted over to arrive at 1, 3, 3, 1. Now let's do it again. 1, 3, 3, 1 multiplied by x plus 1. So we have 1, 3, 3, 1. Then we have 1, 3, 3, 1. And we add again 1, 4, 6, 4, 1. And we can keep going. Now notice something here. On the ends, in all cases, we have 1s. Also notice this 4 was gotten by adding 1 and 3 together, but this 1 actually came from up here. So it's like adding the 1 and the 3 right here together. This 6 comes from adding this 3 and 3, but this 3 was actually over here. So this 3 and 3 add to make that 6. This 4 comes from adding that 3 and 1 together to get 4. So really, we could have thought this way. We could say put 1s on the ends and then say 3 plus 1 is 4, 3 plus 3 is 6, 1 plus 3 is 4, and we get the coefficients for x plus 1 raised to the 4th power. So this is x plus 1 squared. This is x plus 1 cubed. This is x plus 1 to the 4th. We're just multiplying by x plus 1 repeatedly, and we can do it rather quickly. So we end up getting, in particular, x plus 1 raised to the 4th power is, these are the coefficients which we read off as x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. And we have a nice, we've been able to multiply this out. Now these coefficients, we can think about this rule for coefficients in a triangle. We have 1s on the ends. This is like x plus 1 to the 0. This is like x plus 1 to the 1st. This is the coefficients for x plus 1 squared. And then how do you get from one line to another? Put ones on the ends. You add adjacent pairs here. 1 and 2 is 3. 1, 2, 3. How do you get to the next line? Put ones on the end. 3, 1 is 4. 3, 3 is 6. 1, 3 is 4. Go to the next. So that's x plus 1 to the 4th power. How do you get to the 5th power? Put ones on the ends and then add 5. See, that's 10, 10, 5. So that means x plus 1 to the 5th power is x to the 5th plus 5x to the 4th plus 10x cubed plus 10x squared plus 5x plus 1. Thanks for watching.